This conference will now be recorded.
Okay, welcome all to the presentation. The topic for today is AWS training, and yeah, I am the organizer Muzambil Hussain Sheikh, and we'll be running this training for 1.5 hour, 1 hour maybe. Okay, so uh, I'll quickly introduce our trainer for today, Mohammad Arfat. He's a trainer, and he's working as principal software specialist at SAS Pune, and he has more than 15 years of experience, and in AWS he has more than 3 years of experience. Certification, he did AWS Solution Architect certification and Oracle Java certified, and he has been to Germany and Italy as his as on-site opportunities. And this is the email ID. You can get in touch with him after the training for any personal queries related to AWS. Okay, so about this free training, it's only a guidance training wherein we are just showing the roadmap how you can start the career into AWS, or how you can move your career into AWS. And yeah, it is up to individual how to explore further deep into the knowledge, deep into the topic, because AWS itself is a very huge topic, so each and everything cannot be covered uh, in 1 hour session. Okay, so detailed discussion will not happen. It is just like how to start your career, from where to start, what are certifications you can do, and what is there in this AWS for developers, testers, DevOps guys, and yeah, DBS, something like that. Okay, okay. So I'll hand over the call to Arfat bhai. He can start from this topic, this slide.
Yeah, okay. Uh, Thanks, Muzamil bhai, Jazakallah. So, first of all, sorry for this glitch and the delay from my side. So, as Muzamil bhai explained, basically, I've been working with SAS for the last 15 plus years. Been working on AWS primarily as a developer and to some extent a solution architect as well. I did my solution architect exam couple of years back, and it is in fact expired as of now. I do not give the next version of it, the professional version. But yeah, that's a bit about me. Can you go to the next one, Muzammil bhai? Is it possible for you to give me the control, and I'll because I'll be needing this screen share for my further things as well.
Okay, I'll give you the control. Okay, I made you the organizer. I think you should be able to control.
Muzammil bhai, can you see another user I've logged in with? The one I've logged in with from my PC. Yeah, okay.
Are you logged in
So
from other device also, Arfat bhai?
yeah. So now can you see my screen? I've shared the screen.
No, I think I need to. No, Arfat PC is present, but I'm not able to see your screen.
Uh, okay, then there might be a third user as well because I've logged in from my laptop as well.
Arfat PC I can see.
Nothing else?
Arfat mobile, Arfat N is I am. Then simple Arfat, then Arfat PC.
Okay, because yeah. I think this is the one.
Okay. Okay, now it's
So
much
now
better.
you can see.
I can see the screen. Yeah.
Yeah, okay.
Press F5. Okay. Yeah. Yeah,
Yeah.
we can
So
start
as
from this slide.
Yeah. So as said, there's no prerequisite for this session because it's about, for a layman to get started with AWS. I'll assume zero knowledge of AWS. In case if somebody else has this knowledge, please bear with me because I'll be starting from ground up for the benefit of the entire audience. And then basically, once we are through with this course, then later on, depending upon the specialization that is required from your side, you'll need to take up whatever stream you choose from. So if you are from a development background, you can choose the developer stream or the architect stream or the networking. There are a lot of specializations that you can do. I'll come to that on the later part of the presentation. Yeah. So a brief agenda about how we'll be going about this session today is we'll start off with what is cloud computing, what are the options available, a quick tour of AWS services using the console. We'll have a quick look at the services. Basically, following services are major services I'll be covering. The last part, if you can read that, it says Lambda if time permits. So now this is an advanced topic. It comes under serverless computing. So if at all time permits, if there are no not much question and answers or discussions happening, we'll touch base upon this as well. Otherwise, maybe sometime next time. Okay. Then we'll have a look at the pricing model and the ways of accessing the AWS services, the job profiles, and the various certifications that can be done, and from where to start, basically. So, yeah. So now, what is cloud computing? So before we actually go into AWS and dive into AWS, we'll just stop back and first of all be clear what cloud computing is all about. Why cloud computing? So consider you are a startup company and basically, you've got a nice application, a web application developer, e-commerce site, for example. You've got this everything done and developed. Now you want to go live, with the production system. So how do you go about this? Lack of a cloud computing system. You will start off with setting up your own data center, right? Now, once you do that, once you have to do that, what all you need to do is you need to procure your hardware, the servers, the high-end machines that would be required for hosting this particular solution. You've got to connect them. You've got to make sure that they are working perfectly fine behind your firewalls. The security systems. You've you've got to provision for their backups as well. And once you are done with this, then you hook this on to your ISP and you are live basically. But then the question arises, why should I need to do all this? Because I'm not a hardware vendor or a hardware developer. All I need to do is host my solution. So now, ideally, in the ideal world, I should not be needing to do all this. And basically, that's where this cloud computing comes into picture. So assume that you are a Flipkart basically. Okay. Now you've got all the hardwares, all the networking in place, and as per your expectations, and then it does not work out for you. So if it does not work out for you, all the hardware that you've purchased is at a loss because you've got this investment done, and it's a huge investment that you did upfront. But now your business did not kick off. Production systems or in production you were not able to make profits, and you've got to shut this down. So in that case, all this comes right on top of you. But now let's bring cloud computing into the picture. Now what I'll need to do is I'll just need to provision for the hardware that I think I'll be needing for hosting my solution. I don't need to purchase that upfront. I don't need to make that initial cost upfront. So as a startup, my initial upfront cost, initial investment, that actually goes down drastically because I can start small and then grow big as in when required. And basically, with cloud computing, there's this old adage that you do not want to become a victim of your failure or a victim of your success. Now, what does this mean? A victim of failure is pretty much straightforward. Your business did not kick off, and all the initial investment that you did for procuring that hardware or the high end or the high end machines basically has gone for a toss, and you just cannot do anything. What does it mean to be a victim of your success? Now assume that it's the same Flipkart example. Now you are a Flipkart, and you've set up things as per your expectations, that I'll be expecting so and so load and so footprint in my website, and so and so transaction. But for some reasons your business just kicked off, and you had a traffic which is more than your initial expectations for which you've set up your hardware. Now what happens is your entire site crashes. So now you are becoming a victim of your own success. But basically, when it comes to cloud computing, this all is taken care of. How we'll be seeing this in the subsequent slides. And basically, when we talk about cloud computing, there are three primary principles that apply. One is infrastructure as a software, second one is platform as a software, and third one is software as a software. Now, software as a as a service. Now, when we talk of software as a service, this is pretty much straightforward. You've got a software. Now you are, instead of giving this entire software as a package to the end customer, the binaries of the software, the source code, or whatever that be, the exes of the software to the end customer, and asking them to install it on their machine. You are providing this as a hosted solution such that the end customer can directly access this one. So this is pretty much straightforward. Infrastructure as a service and platform as a service, these are they've got a very thin line in between. Now when I talk about infrastructure as a service, uh, you've got you give more control to the end user in terms of accessing the underlying hardware. Whereas when it comes to platform as a service, there is a specific platform that you provide to the end user. And basically, in this entire space of cloud computing, you've got this listed out on the slide as well. The options are AWS, Azure, Google Cloud, and there's this open source cloud, OpenStack as well. When we actually look at the scenario outside of these four, there are other providers as well. But then, as a whole, there's nothing. Somebody like Heroku or a Rackspace, they either are infrastructure as a service or platform as a service. They don't necessarily cover all the bases of the software development, deployment, and whatever it takes to get your things live. So maybe something offers you a mechanism for storing your messages in a very efficient way. Somebody offers you a mechanism for giving you compute resources, and somebody offers you a mechanism for giving you resources for your messaging or streaming. But then when we actually combine this as a whole and look at the whole picture, these are the options that emerge out. And basically, in case of cloud computing, there's another important concept called as tenant. Now, in the traditional software development, when I go that way, I'll be I'll be developing my software, and once I've got this software developed package, I'll be distributing these binaries to the end users. So these entire customers of mine will be running on segregated hardware, or completely distinct hardware of their own, of their choice, and they've got no relation with what other is running on. So there's no interdependencies. Whereas when we talk about the cloud computing part, this is where it differentiates. The same set of hardwares, the same set of servers, the same set of underlying network connections are serving all your customers. I will not create a separate cloud for one customer and a separate cloud for another customer, because that just takes me away from the purpose. The whole purpose is, I am serving everybody from the same infrastructure, and it's the same underlying hardware that's catering to all the needs of all the customers. So there's a mentality change involved in here when you actually develop software, when you actually deploy software of these types, because it should not just happen that a customer's data gets mixed up with another customer's data, or the other one is actually able to see somebody else's data. So that's where this gets even more critical when we talk about the cloud computing part. So, let's say, for example, just to give a complete example, a library management software. So I've got a library management software. Now, if I've got to provide this software as a service, what I'll do is I'll host this software somewhere. It can be outside of cloud as well, or outside of AWS as well. And then I'll onboard the tenants or onboard the customers as tenants on my hosted solution. Whereas if it was the traditional way, I would have just given it on a CD to different colleges or different institutions, and they can just run this entire software within their own private network, within their own hardware. Whereas in case of software as a service, this does not hold true. So these are primary concepts which are making up the cloud computing part. So then, this was about the cloud computing part. Any questions so far? Just one thing I would like to say is I would like to keep this session, interactive. So if there's a question, you can just ask it there and then itself. You don't need to hold this right till the end. Maybe we'll have a question and answer session at the end. But if there's something, you can just stop me at that point in time, and we can just clarify doubts as we go along. So this was about
Yeah,
cloud
Arpad,
computing.
one thing.
Yeah.
You put some points on AWS, Azure, and Google Cloud, how they share the market share,
Okay.
which
So
is the top one.
basically, right. AWS is the top one because I'm working on it. So, no, to be frank, ever since I started working on cloud computing, I've not got the luxury or the privilege to work cross cloud platform. It's always been AWS, and basically in our company, ours is the only product that's working on core AWS, because otherwise people are trying out OpenStack as well, and a combination of hybrid cloud, something from Azure, something from Google Cloud. But our product is said that we were the first product to adopt in our company to go the cloud way, and we adopted AWS, and the company is fine as such with us sticking around with AWS. So I'll not be able to compare exactly, but from what I know is, AWS has the maximum market share when you look at the overall picture. These guys were the ones who came up with AWS Lambda, and then this was adopted by other clouds as well. Azure is picking up, and the peculiar thing about Google Cloud is, this they are trying to catch up, and they are trying to be very aggressive when it comes to pricing. So their pricing is for nearly for all the services. I've not compared it because I've not got the need to. But what I know and what I've read and what I've heard of is their pricing is very aggressive, and for most of the services, they offer cheaper options than AWS. But AWS, it has, as I said, all the bases covered. We'll see in the next subsequent slide. It's just coming up with options for all the upcoming trends and technologies which are there, be it analytics, be it blockchain development or machine learning, AI, you name it, and they've got services for each of those. So that's how it stands. And basically they are the market leaders when you talk about the cloud computing. When you actually go into different areas, so maybe Google Cloud would have a slight advantage in, say, for example, compute services, or Azure might have some advantage in terms of storage services. But in terms of overall picture, AWS is having the maximum market share. And then there's this OpenStack, which is coming up very nicely as well, where you are not tied in with any of the vendors, and basically it goes the open source technology way. So does it answer the question?
Yes.
Okay, fine. So
Hello.
yeah.
So yes, Arafat, you said like you have given the example of library management system. So like in the cloud way, so we will share the WAR file or binaries instead of the exe file. Am I correct?
No, not at all, not at all. We would just not share anything. No WAR file, no binaries, no EXEs, no DLLs, nothing. We'll just host this. And so, for example, let's say, for example, I'm getting started with my, I'm done with my development of my library solution. What a library management solution. What I'll do is I'll host this somewhere. And say, for example, tomorrow, a company comes and says, okay, or the institution or a college comes to me and says, okay, I want to, have your library management system. Now what I'll do is I'll onboard these guys as a tenant on my existing hosted solution. I'll not share any binaries with those guys. I'll give them create the credentials for those guys. I'll give them the login IDs, and then they can start using my software. And basically, their data will be segregated behind the scenes, but it will be serving from the same set of shared hardware which is serving the other tenants as well. So tomorrow, if there's some other college that comes to me and says, okay, I want your library management software as well, I'll onboard these guys as well. So tenant onboarding is equivalent to selling a software to a company in the traditional world. So that's how this differs. So you just do not share anything with those guys except for how do they access the software. So clear?
Okay, thanks. Yeah, good.
Okay, fine. So then we'll move ahead with getting more into AWS. So now when we actually talk about AWS, as the name suggests, as Amazon Web Services from Amazon. So the topmost thing is AWS accounts. So when you want to get started with AWS, first and foremost, you've got to create your account with these guys. And basically, for creating an account, you need a credit card. They at the time of account creation, they'll take your credit card details. They'll deduct 2 rupees from your credit card. That's refunded back. That's basically sorry. That's basically for the validation of the credit card. So now if you can see in this particular screen of mine, this is my company's AWS account. I've blacked out the account numbers and the account names, but you can see we've got 4 accounts with AWS. One is the topmost is for demoing. So we've got our software up and running. We've been working on this for 3+ years now. So if there's a demo to be done, you will be doing on this topmost account. Then we've got this R&D account. This is where all our development happens. So all the development, testing, everything, this happens on the second account, which you can see. Then we've got the third account, which is the production account. I've just masked it completely. That's where all the production code goes. And then we've got this fourth account, which is for the staging part. So we before going to production, we have a staging account in between where we test things out for the thoroughness, and then basically from staging it goes on to production. So basically, if you've got multiple accounts, and this is a federated identity which we've connected our LDAP, Office LDAP accounts with the AWS account, and that's where you can see these 4. If you go and create your account with an email ID, you would actually not be seeing all these 4 options. That's why I put in a screenshot in here. So once you've created your account, it is associated with your credit cards, and now you can start using the services from within that account. Now, the second thing that comes is the AWS regions. So basically, right now, AWS is operating in 14 different regions, and you choose. And in fact, even the pricing varies very slightly from region to region, not drastically, but from region to region, and even the service availability varies from region to region. So usually when they launch their new services for something, they don't launch it in all the regions. They start off with a couple of regions, and then depending upon its success and all, they just expand this gradually to or roll out this to all the other regions as well. So they've got a couple of regions in US. Then in Europe, they've started a region in India as well. They've got a region in China, and basically the reason for having these regions is uh, it's with the financial institutions. They don't like their data to be going out of their country or out of their continent. So basically, and basically, within these regions, they've got these availability zones. Now these availability zones, they are the actual data centers where all the hardware is provisioned, and the data is replicated. So if one availability zone goes down, they can still get your service requests being catered from the other availability zones which are there. So just to get a clear picture about what these regions and what these availability zones are, I'll just take you to the AWS console. And before that, and we'll just talk about the last point as well, which is AWS services. Now we talked about regions, we've talked about availability zones. uh, Services are basically different types of services that they offer, be it in case of offering you a compute service, or offering you a storage service, or offering you a messaging service. And there are different categories. We'll just see this in the AWS console, so that will just clarify the picture further. Yeah. So this is my AWS console. Okay. And basically, if I just expand this one, before that, we'll talk about the regions. So these are all the regions which are available. You've got US East, then US, basically two in US East, two in US West. Then you've got the Asia Pacific, and within Asia Pacific, you've got the Mumbai region, the Seoul region, then there's the Sydney, then you've got the European region, South America. So these are all the regions. And basically, and each of these regions will have multiple availability zones. Now, when we talk about services, now this is yeah. So these are all the set of services that AWS has to offer. You've got compute service. Let's say, for example, we talk about the compute service. Now, this is the service which would be used by everybody and anybody, mostly who is using in AWS for cloud computing, because first and foremost, it provides you with EC2 instances. We'll have a look at what EC2 instances are, but just to give a heads up, these are similar to your virtual machines, where all your hardware and all your software is actually running behind the scenes. Then they've got this AWS Lambda, Elastic Beanstalk. So we won't go into details of each of the services. The purpose here is just to show you the categories in which they cater to your request. They've got the storage service. Now, this storage service actually is not the database service. This is block storage. So they've got a separate database service as well, which supports Redshift, which is for data warehousing, DynamoD, which is for NoSQL, then the RDS, where you can have your oracles and the MySQLs running in there. And the storage service is basically, it's just about object storage. So you have an object, you store this, and you retrieve this. You just cannot do anything more with that. We'll talk about the use case and how S3 basically works. Then having a look at the other services, they've got services for game development as well, for IoT as well, for the machine learning, the media services. This is for your video streams. So if your project involves streaming data, streaming video data, then you would be using one of these services. Okay, then this migration transfer service. So depending upon what domain or what upcoming thing you are looking for, they do have services for nearly everything. Now, developer services, they even offer you remote workstations, so you don't need high-end machines for even development. You can get it from those guys. So this is the overview of different services. So I hope the concept of a region, availability zone, and a service is clear. So a region is the topmost region. Region is a region, basically, where this service is available. And within each region, they've got different availability zones for failover support. So if one availability zone goes down, they do have this data replication, where your data is not residing only in a specific availability zone. It will be replicated across different availability zones, so that if one goes down, they can still cater you from other availability zones. So when we talk about these services, some of these services, they are global services, meaning they're available across region, and some are regional services. Like, for example, EC2 is a regional services. So a EC2 created in a Europe region will not be able to communicate with a EC2 which is created inside the, so for example, US region, unless you specifically, do this VPC pairing within their systems. Whereas there's this other service which is for authentication and authorization. This is a global service. This is available across regions. So if you create a user or a role within a specific region, that role and that user is available across different regions. So all the regions will be having access to that particular role, and it is not specific to a specific region. So there's a difference. So some services, most of the services, in fact, they are regional services, meaning if you create an instance of that service in a specific region, you are restricted to that region. If there's another service, similar service running in another region, they've got no connection unless you specifically, connect these two specifically. And when we talk about global services, they are just available seamlessly across different regions. So any questions on the region, the availability zones, and the services?
I
Okay.
think we can move on.
Yeah, so we'll move ahead. So first and foremost service that I'll be talking about is IAM. And before that, just wanted to give a heads up. There's a service called as VPC as well, which is creating a resource set within a specific region that is grouped together. So VPC, you can treat a VPC or look at the VPC like a VPN within your company. So nobody from outside can access a resource which is present within your VPN unless you provide a gateway through it. Same holds true for VPC as well. I've not listed out over here because that's a complete huge topic within its own. And if you are actually going in for certification, this has a lot of weightage. It is very complicated and it has a lot of weightage. A lot of questions they do come from for the solution architect exam from the VPC part. So just to give a brief idea about what VPC was. Now IAM is their identity and access management service. So this service basically enables you for authorization, authentication part. You create users, you create groups, you create roles, and then you can assign the different policies. You can allow access, you can deny access to a specific resource. And the good part about it is different services which we had a look at in the previous slide. They do communicate via each other, or they do get access to each other using these IAM roles. So for example, I've got a EC2 instance, which is my virtual machine analogy, and I've got a S3. Now if I don't attach a role which says this EC2 can actually access an object from S3 or put an object in S3, I'll not be able to do that. So all these services, they are connected via these IAM roles. So IAM roles is just not only for users, it's for the services to communicate with other services as well. It's for user to communicate with the services, it's for service to communicate with other services. So you create your own permissions and policies, and then you attach it to the users and groups, and then you attach these and basically you attach it to the roles, and then you attach the roles to the corresponding services. So IAM supports identity federation as well. I got a question mark from Nayab. What was that? What was not clear in this one?
There's one more message before that.
Sorry?
There is one
Hi,
more
this is
message before
Syed.
that.
This is Syed Naib.
Yeah.
Regarding without VPC, that is not possible to connect EC2 in one region to the east to another region. Is not possible.
No, come again.
Without VPC creation, virtual public cloud creation, is it possible that you can connect the two EC2s in different regions?
No, it is not possible.
Okay. Actually, I didn't try on that one. Okay. With VPC, we can do that. Okay. Thanks.
Yeah, you need to do VPC pairing in that case. You need to pair the VPC, and then only you can actually connect from one region to another. So this VPC pairing is a complete topic in itself, wherein you connect different regions.
Yeah.
Resources can communicate.
Yeah. Okay. Thanks. Yeah.
Okay. Fine. So coming back to this IAM, basically IAM supports identity federation as well, and that's what we do in our company as well. So basically all the accounts that we've got, all the AWS accounts that we've got, we don't have any separate logins to connect to those accounts. Basically, these are connected to our LDAP using Federation Identity Federation, and you can not only connect to your local office LDAP, you can connect this to LinkedIn profiles and Facebook profiles as well. So you can log into your AWS account using your Facebook account, using your LinkedIn account. So this is what IAM supports as well. And yeah, as we talked about, this primarily consists of these four things. They've got the users, they've got groups, roles, and policies. Now, you policies is where you basically define a allow or a deny for a specific resource. Then you attach this policy to a role, and roles can be attached to services, or you can attach these to the users and group, and then accordingly they'll be getting rights to different services. So somebody can access EC2 service, and somebody cannot access a EC2 service. And the reason for that is the role that they've got attached to their user is not having the corresponding rights. So nothing very different from what we do in the traditional world, but then just the lingo in the IAM service. So clear on this one? Okay, so I'll move on to the next service. Yeah, so the next service that we'll be talking about is the EC2 service. EC2, it provides you secure, resizable compute capacity in cloud. This is the most widely used service within the AWS. So a lot of people, if you hear them talking about, they are actually working on cloud, it is quite possible that the deployment is on EC2 instance, and they are just using it as a VM. So nothing much that they do about using that as a cloud service. But yeah, that's how this EC2 pans out. Now, basically, this is available with Windows and Linux flavors different. So you've got a SUSE Linux as well. You've got a Red Hat Linux. You've got Ubuntu. So all these Linux flavors, they are available in your VPC. In your EC2 instance. So when you define your EC2, you select a operating system upfront, and then based on that operating system, you get a virtual machine, which basically you can just use as any other machine which you've got access to. So the different types which are available in this are when you do a reservation for a EC2 instance, these are the different types of reservations you can do. You can have spot instances, you can have on-demand instances, and you can have reserved instances. Now, basically, they primarily differ in terms of their costing. Because if I talk about reserved instances, I say this to Amazon that I want to reserve these many instances. Now, even if I don't use those instances, I'll need to pay for them. But the good side is I'll be getting them at a cheaper rate as against to on-demand instances. On-demand instances are the ones where you just say, okay, right now give me an instance, and then basically the cost of this particular instance would be much higher than what you have for reserved instances. So ideally, when we actually go into this one, when we do planning, you should know upfront what your expected capacity would be, and then you can actually go in for reserved instances. Now, the third instance type is spot instances. Now, these are basically the instances which are available on a per hour basis, and you bid for those instances. So the highest bidder actually gets this particular instance. But the issue with this is the next hour, if somebody else bids higher than you, your instance is gone. So a question comes up: what is the use of such instances? First and foremost, they are very cheap, cheaper than on demand and cheaper than reserved. They're damn cheap instances. So, but then if it just goes off, what do I do with that? The use case for such types of instances, the spot instances, is you've got some batch processing to do at your end. You do a nightly job, and you've got to do some batch processing. So what you do is you spin up a spot instance, you bid for that, you get that, you are doing your processing, and the very next hour somebody bids and your system is gone. But these are the type of jobs where you can do this again. So you can start off from scratch and start your batch processing again. So these are for those non-critical jobs that even if the instance underlying goes away, you are least bothered about it. Or for example, if you want to just add some extra capacity to your fleet of EC2s which are there, you can even in that case go in for these spot instances. So that's primarily the use case of a spot instance. And basically when we talk about EC2, just to be very clear, this is just like a virtual computer. It has RAM, it has CPU, it has hard disk, it has networking enabled, and it is no different from any other computer, just that it's there on cloud. So just like you install any software on your local machine or on your server, which you've got physical access to, you will be able to do this everything on EC2 instances. But just that when it comes to cloud computing and AWS world, we call them instances as against to machines or anything else. And then you've got a series of different types of EC2 instances which are available. So you've got memory optimized, you've got compute optimized, you've got GPU optimized, you've got storage optimized. So for example, if I'm developing a gaming system, okay, and that's what I'm requesting a EC2 instance for, or I'm willing to get a EC2 instance. In that case, I'll be going in for a GPU optimized instance. Or if I've got to do some compute intensive operation, then I'll be going for compute. So these are different types of instances. The rates of them, each of them vary, and the area that they cater to vary as well. So you should be clear about what your requirement is, and then accordingly you can actually choose one of them. Then there's this general type as well. So that's just having something of this, and basically if you're not sure, you can start off with that. And in that case, tomorrow if you feel that I need to switch over to a different instance type, you can still do that. But in that case, be very sure that if you switch over from one instance type to another instance type, it cannot happen without a downtime. So ideally, you should be knowing what your instance types should be. Okay, and we've got these things in the ecosystem of EC2 instances which are working. One is AMI. Now AMI is Amazon Machine Image. This is a pre-baked sort of machine, pre-installed sort of machine. You've got a lot of pre-baked AMIs available from AWS. So if I go back to the EC2 instance part, we'll just have a quick look at this one. Yeah, so let's say for example I say I want to launch a new instance. So this is the EC2 console, basically AWS console for EC2. Now it lists out all the available types of AMIs. So you always create it based on you select a type, and basically it comes pre-baked. So for example, if I go with the Amazon Linux AMI, then it will come pre-baked with a Amazon CLI as well. So I don't need to install a CLI if I want to access Amazon via command line interface. So this comes pre-baked with that. Similarly, there are different types of things. So let's say, for example, I go ahead and choose this one, or rather the first one. So the next thing, it'll ask me is what type. So this is a general purpose thing. If I scroll down, I'll be able to see compute optimized. So if my operation is compute is intensive, I'll be using these types of instances. Then you've got the GPU, and similarly for memory optimized. So depending upon the need, I'll just choose one of them. So let's say for example, I just go ahead with the general purpose thing, and I say configuration for this one. So now, just like previously we said, it's just a computer that's having a CPU, hard disk, RAM. So now I can here, I say request spot instances, and I can choose my bidding price. If I don't do that, this will by default, fall back on the on-demand mechanism. So you can choose whatever you want. And then you've got this VPC. You select which VPC you want this to be part of. Now in my system, I've got just one VPC, so it's listing out only the first one. Otherwise, it'll just tell me, give me all the options. I would select the VPC. The next thing it'll ask me is I'll need to choose the subnet. So based on the VPC that I selected in my previous step, it'll list down all the subnets which are available for that particular VPC, and I can just choose one and go ahead with that. I can choose to assign a public IP to it, and basically, yeah, I can choose an IAM role. Now I don't have any IAM role, so let's say for example this EC2 instance was supposed to communicate to S3, write objects to S3 and read objects from S3. I would have to create IAM role which is giving permissions for read and write to S3, and then choose that role for this particular instance type. And then there are other things like shutdown behavior, all those things. We'll not go much into details of that. And then in the next one, you add the storage. So this is a sort of hard disk that you are trying to add to your EC2 instance. You choose what type of GPU, or rather what type of what configuration you want. So we'll not go into details about these types of hard disks, or basically they call it elastic block storage. That's what they call in the AWS lingo. But you can take this to be a hard disk that you are attaching to your system. So you attach one of them. The next thing that you try to do is you add the tags to your resources. Now tags are something that helps you identify or rather help you out with the billing part. So you can attach a tag called based on department. So for example, this is for HR department. So I'll attach a HR tag to this, and later on when I get the billing, I can get this group by give me the entire billing for the HR department. It will just go over here, scan all the tags for all the resources, and basically it will just go further. So you can just
Okay.
attach whatever tag you want.
Arfad bhai.
Yeah.
Yeah, sorry to interrupt. I think we have only 15 minutes left. We are running at 10, 15 now. So we have so many things to cover. So we need to adjust all this content accordingly.
Okay, fine. I'll do that. So
Yeah.
just a quick one, last one over here is you just select your security group basically, and basically this allows incoming and outgoing ports to your machine, and then you say review and launch, and that will just provision EC2 instance for you. So basically this was about the EC2 instance. The next service that we'll be talking about is S3. Now S3 is an object storage, meaning it can store only objects. So let's say for example, if I want to install an operating system or a database on S3, that's not possible. It is one object, an independent object that I want to store and that I want to get back. Now the files that you store on S3, it can be from 1 byte to 5 terabyte. And then you've got this S3 availability, basically, which is saying that Amazon guarantees that this service will be available for 99.99% of time, and the durability. Now this is 11 nines, which means that if you put these many objects plus one object, there is a chance that only that one object is getting lost. So that's the high level of durability that they actually guarantee. And the way they do it is because they are replicating this data across different availability zones. Then S3 is basically having a concept of buckets. So you create buckets within your S3 service, and then you store objects within the buckets. Buckets are a global service. So if somebody has taken a bucket name called as my demo, nobody else in this world can using AWS S3 can have this bucket name. So these are global, not for your region, not for your availability zone, not for your account. It's global across all the accounts of AWS. So that's what about the buckets. And then these are different storage classes. We'll not go much into details. Last one I just want to iterate is the Glacier one, which is a very cheap storage mechanism. But the catch is these are for your archives. So if you put something in Glacier, and if you want to retrieve that back from Glacier, then sorry, you want to retrieve back from Glacier, then the retrieval time is not instant. basically it is taking you hours and 4 to 5 hours to get the object back. So it is not for your day-to-day ideal storage. It is for storing your archives, which you would need at a later stage. And then there's this ecosystem for S3, which is buckets we talked about. There's this notifications and life cycle management. Notification is, S3 can actually communicate with other services, like for example Lambda, which is which the server is offering, or it can compute talk to SQS. Whenever a new object is put in this bucket, if I've set the notification, it will just send the corresponding notification to the other service which is connected. And the lifecycle management, I can set lifecycle hooks on S3, set that I say, okay, for as soon as the object gets 1 month old, transfer it to Glacier, so that I don't have to pay the high cost of retaining that object. It just gets transferred to Glacier, and the costing is very low on that side. So any quick questions on EC2 and S3?
And I believe people are following us. Yeah, I know it's we have more than 20 minutes now, but still we'll try to pack it up within next 10, 15
sure.
minutes.
Yeah.
Yeah, everyone is with us?
Yes, yes.
Okay.
Okay.
Yeah,
That's
yes. Yeah.
Okay. So the other part is, I'll not go into deep details on this one, but the reason I started, or rather I put SQS, is because AWS puts a lot of stress on SQS, because it all started with SQS. So when there was no AWS, they just had basically SQS is a queuing service. So people who are from development background or from testing background have worked on queues, the JMS topics or Kafka topics. So it's a queuing mechanism. You put a message, somebody else, you publish a message, somebody else will read the message from the queue. So they had this queue, they developed a queue, they hosted this queue and made it available for everybody else to use, just to try this out. And then it clicked and it worked. And then came along AWS and all the services that AWS has. So it's a reliable and scalable hosted queue. Single queue can be used by multiple applications without worrying about coordination. So you can put a message, and then one of the consumers can pick the message up and do the processing. Now this is the use case for this is decoupling your application. Again, for people who are from code development background, you want to decouple your application. You don't want one module to be dependent upon other module, so that if the other side of the module is down, I would still want to continue with this side. So the way you do it is you create a job for the other module. You put this on SQS. Even if the other module is down, wherever it comes up, it will read this job and will do the processing of this particular job and get things done. So that's the use case for this one, and it's a pull mechanism. So you've got to go to the queue, you got to read the message, or rather pull the message out. It will not push the message onto you. It can be used with auto scaling as well in EC2 instances. Then message attributes. So basically, you can set attributes so that you can filter. Okay, I want only these type of messages from the SQS queue. And then these are some internal details, like it ensures delivery of each message at least once, and does not guarantee a first in first out delivery, although they've come up with a alternative queue, which is FIFO queues, which actually guarantees that the messages that you retrieve on the other end will be in the same sequence as the message that were dumped in from this end. So that was about SQS. And basically redundant infrastructure. This holds true for all of the services of AWS. All these services, they've got redundant infrastructure. They replicate data across different availability zones, different computers, so that if one goes down, you are still not losing out on your data. Then you've got these are just the details, nothing much in this one. But then you've got a dead letter queue as well, where if nobody is able to process the message, so if, say for example, the message which you put or the job which you put, it was corrupt, nobody, everybody tried, but then nobody was able to consume this message, then you can set a dead letter queue, so that these type of messages go into different SQS, and you can do this server side encryption as well, so that your data is protected on the other end. SNS is similar to SQS, just that SNS is a broadcasting system. Now we said when we talk about the SQS, the producer will put the message on the queue, and the consumer, only one of the consumer will actually get the message. So the use case for that was decoupling, because you wanted to upscale. So for example, if the messages, incoming messages are coming at a very high speed, and I want these to be consumed faster and processed faster, what I'll do is I'll attach multiple consumers at the other end, such that somebody picks the first one, somebody picks the second one, somebody, and that just goes on in round robin fashion. But when it comes to SNS, this is a broadcasting system, a publish subscribe mechanism, where a message, which is put in by the producer into the topic, is broadcasted to all the consumers which are present at the other end, irrespective of what processing they do. They all get the same message, and they can just do the same processing, or they can just opt to do different. Ideally, when it comes to SQS consumers, they are all doing the same sort of processing. When it comes to SNS consumers, they are all actually doing different types of processing. So ideal case of this would be, somebody puts a message on S3. Okay, now let's, for example, I am Netflix. Okay, somebody puts a video clip on or uploads a video clip on my location or on my website. Now I'll get this into S3. S3 I'll create a notification for S3, said that whenever there's a message, notify the SNS topic. So now this will notify the SNS topic. SNS topic will have multiple consumers. One might just take this message and watermark this and store it. One might transcode this and keep this. One might just make different versions of this one. So if it was MP3, I just wanted to create thumbnail out of this one. One of the consumers will just create a thumbnail out of this and store this. So all of them worked on the same message, but all of them did the different sort of operations on each of the messages. So this was SNS. And these are the supported endpoints, consumers, which you can attach to the SNS topics. Okay. Now, cloud formation. This is a very important, service which is there from AWS. This is basically, you have your entire infrastructure as code. It can be versioned just like your source code in you do for your source code in Git or some other repository. You can even version this one. Okay, and this is basically done either using JSON, and of late they've added support for YAML as well. So there are two important things in this one. One is your template. Your template decides what all resources will be part of your stack, and stack is what you get out of a template. So people from a Java background, I can just say templates are like class files, and the stacks are like objects created from those class files. So different. So based on the attributes, I get different objects, just like that. Based on different attributes, I'll get different stacks. But then all of them will be having a similar look and feel, and all of them will be serving the same sort of purposes. So that's what this cloud formation is all about. And the advantage of this is, it's repeatable, updatable, deletable, versionable, testable. Basically, what I mean is, I've got a complicated. So in our company, for my project that I'm working on, I've got 15 plus EC2 instances. I've got SNS, I've got SQS, I've got Redshift clusters, I've got DynamoDBs. All of these things, they entirely packaged together make up my entire stack. That is my enterprise stack that will be serving my customers. So now, if I want to create this manually, it's quite possible that I miss out something. Or for example, I just want to update this one. I'll have to go and update each of the pieces separately. Or if I delete this one, this is a big problem for me, because if I forget to delete one of the resource, it will be very difficult for me, in case of my billing part. So CloudFormation takes care of all of these things. There are no leftover resources, and basically this service is completely free. You only pay for the resources that you create out of CloudFormation. Then we've got this CloudWatch. This is basically for monitoring your AWS. It provides you with different type of matrices. It provides you with logs that you can store. And the advantage of CloudWatch is, even if the behind the scenes. So basically, let's say for example, I've got an EC2 instance. Okay, I've got the CloudWatch agent installed on my EC2 instance. Now all the logs I'm dumping on the CloudWatch. Tomorrow my EC2 instance is killed. I just don't need the. So I had 5 EC2 instances, but because of lack of traffic, I don't need 5 instances. I just leave 2 instances. I kill 3 instances. But tomorrow, if I wanted to access the logs from those instances, they would just be gone. So what CloudWatch does is it persists the log. You specify retaining period, and it retains your logs for those many days, basically whatever you specified. So it's near real time. Then you can integrate this with search engines like Kibana. You can apply analytics to those things, and we'll not go into this part of AWS integration with this one. And you can export these. So I can set my export criteria that export the logs to Glacier. So then I've got my logs archived as well, and at a very cheap rate. So that's what CloudWatch is for. So yeah, these were the services I want to cover primarily. So any questions, quick questions so far? No. Okay. So we'll move on to pricing. Now, basically, whenever you create AWS account, it offers you a free tier usage. And basically, there are a lot of things that you can offer. You can get in terms of ELBs, in terms of EC2 instances. You get 5 GB of storage from S3. But this is just for first 1 year. And see, we need to understand one thing, that AWS or Amazon is not there for charity. They are there for business. So, the purpose for this is they want you to get used to it. They first of all want you to use it, get used to it, and then get hooked onto it. So you've got to be careful, because these EC2 instances, they actually start charging you after the first 1 year is over. So this free usage is only for 1 year. And basically, I had a bad experience with this one, because when I started off with AWS, I was doing a course on Coursera, and I created a AWS EC2 instance. That was a free instance at that point in time. And after the course was complete, I just deleted all the resources. But then all of a sudden, one day I got a bill of 2,500 on my credit card. And I was shocked this was coming from AWS. I went in, logged into the AWS console. I checked out all my resources which were there, but I just could not find anything. I was not clear what this charge was for. So I called up the call center guys, and I said, I've got so and so charges, but I just do not see any EC2 instance. You charge me for EC2 instance, but I do not see any EC2 instances in my thing. So how's that? He said, okay, what do you see at the right hand top? I say, okay, I see Oregon. He said, can you just scroll down and go to the EU West region? And I just knew that I've got a EC2 instance lying there. So, you've got to be very careful with this one. Whatever you create, you try to, if you're experimenting something, you stick with one region. You do not scatter your resources across different regions. And as far as possible, create your resources via CloudFormation, so that the moment I say delete the stack, it will just leave no residue. It will just delete all the resources which it had created, so there can be no leftovers. So this was about the free tier. And the costing factors are based on number of requests that you do for different resources, the data transfer. So these are the factors that actually drive your pricings for AWS resources. And they offer you a trusted advisor as well. Now, if you see at the leftmost thing, there's this cost optimization. So this gives you a nice picture of what you can optimize on your cost front. If there's EC2 instance lying in there for some time and you're not using it, you'll just highlight it over there, and you can go ahead and delete that particular EC2 instance. Okay, so this was for the pricing part. Now, there are different ways of accessing the AWS services. One is the AWS console, which we saw. We logged into the console, we saw different services. We tried to create a EC2 instance. Likewise, you can just access any of the resource or any of the services from AWS console, and that's one of the most common ways of accessing AWS services. The other one is AWS CLI. It's a command line interface. So you go to your DOS prompt or your bash shell, and from there you can access resources, you can create resources, you can delete resources. So almost everything that you can do from your console, you can actually do this from CLI as well. And then you've got this AWS SDK. Now this is where all the developers come into picture, because you would create a EC2 instance, you would create a S3 bucket, for example, from console or CLI. But eventually, when you want to use those, your code will be sitting on EC2 instance. Your object that you're putting into S3 and you're deleting from S3, you will not be going and deleting and those things manually. You will be doing this via the SDK. So they provide SDK support for Java, .NET, Python, PHP, Go, Ruby. There are a couple of more as well, and they're just adding to the pie. So majorly you basically choose a language and then you stick with that language, and then you access all the resources and do all your programming in that language using these AWS provided SDKs. And the last one, not very important one, is you can access them via the visual editor plugins as well. Like for example, Eclipse has a plugin for AWS, but nothing much you can do as such, but you can still access. So this was about it. Now we'll just go to the jobs, roles, and certifications. So, first is software development. So if you are a developer, you can just do your development. As we saw in the previous slide, AWS SDKs are available in a lot of languages. Whatever language you are using for your development, or whatever you're comfortable with, or whatever your mandate is from the company, you go with that language, and you've got to get a handle on the AWS SDK. They offer a certification as well, specifically for the developer part, where instead of concentrating more on the different services which are there, they are trying to grill you more on the SDKs basically. So it basically is working with Python, I guess. I'm not doing that certification, but they concentrate more on Python when we talk about the developer certification. Then you've got this cloud architect. So the job role of a cloud architect is he should have a good handle of all the services which are available from AWS. How do they communicate with each other? What are the relationships, for what scenario I can use what service? And if you look at the cloud architect certification which I gave, there are a lot of scenario based questions. They'll not ask you dumb questions for you want to do this, and which method you do. Rather, they'll post you or you pose you with a scenario saying, this is a company that's come to you, these are the scenarios. So for example, Netflix came to you and Netflix says, I want to do these things. So whenever somebody uploads an object, first of all, I want to store those video clips that are sent to me. Then I want to stream those back. And whenever somebody gives me a video clip, I want to watermark this. I want to create thumbnail out of it. I want to create 10 different versions of it and store it. So now for these scenarios, what are the services? They'll list down the services, and they'll ask you to pick and choose the services which will best suit this particular use case. So as an architect, you should be having a fair handle of, you might not know all the services in depth, but you've got to know such service exists. Like for example, of late they've introduced a Kafka service. So Kafka is again basically queuing mechanism, but now they are just directly offering Kafka as a service. So you've got to know if there's a service called as Kafka service, and then you can connect the dots later on. You cannot just work with EC2 instances and S3 buckets all the time. You've got to know the major ecosystem which is there, and it's quite difficult to keep up with the pace, because they are actually adding up services at a very rapid pace. They've got around 130 plus services already into their gambit of services that they offer. And then you've got to have design considerations when you're integrating with third party, because
sorry to interrupt. It's 10:35, so we need to quickly wrap up this session.
Yeah, 5 minutes.
Yeah, 5 minutes. We need to take feedback also, any QAs.
Yeah, sure. Okay. So here basically, you need to take care of integrating with third party, because you need to be aware that all the tenants, all the customers of yours are going to communicate with the same third-party software, if at all there is any. Then it should not happen that one is just consuming the entire capacity and nobody else is left with. So all these things come under the cloud architect role basically. Then you've got the DevOps role. So primarily it is about deployment, monitoring, notifications. S3 AWS offers a very strong notification mechanism as well. So you've got to have this mechanism in place that automatically a pager goes out to somebody who is on call if my server is down. I don't need to monitor this, sit there and monitor this manually. Maybe create dashboards or matrices, whatever that be. But then that's what is primarily covered by the DevOps role. And then we've got the networking role as well. So, VPC is a primary component when we talk about the networking role. So you can even have a VPC connect, wherein you are actually connecting your local VPN network to the Amazon's VPC within your account. Then there's this storage gateways. These are, for for syncing up data S3 with S3 basically. So if you don't want to have your archives locally, you can even sync them up by having a storage gateway set up in your premises. And then yeah, testing basically just needs to have a handle to all the services, so that whatever bug or defect comes in, or they have to find it, they can find their way into the service and don't need to go back to the developers about, for example, I'm not seeing a message in SQS, how do you check that? So should be self-sufficient about using the services, at least from the AWS console, if not from CLI or the SDK. Okay, so certifications basically, these are the certifications that are there. The certification pricing is for the cloud practitioner, that is a very basic thing. They charge $100. For the associate exams, they charge you $150. And for the professional exams and the specialty exam, it is $300 basically. And the path is for you to go to the professional way, you've got to first clear your associate, and there's no need for you to be to clear your first level of cloud practitioner to go to the associate exams. So these are the certifications that they do provide. And here's a quick look of where we can start. So first is the AWS documentation is fantastic. It is self-sufficient. You don't need to go anywhere else. You can just log into the docs.aws.amazon.com and you just get everything. Then they do provide training materials as well. A lot of them is free, a lot of them is paid. You can just have a quick look. And then if you want to go for some online training, then acloud.guru is one of the best sites that, if certification is what is in your mind, then for sure acloud.guru is one of the best resources which is available. And apart from that, there's this reInvent videos. Now reInvent is their annual program that they conduct in US, and that's where they announce your new services and upgradations to the existing ones, and all the announcements are done in the reInvent. It's a very high profile high profile program that they conduct. It's a 2-day thingy, and then nearly 50,000 people attended this year's reInvent, and all the videos are available on this particular thing, so you can just go there and have a look. And then they provide you with reference architecture as well. So if your use case is, for example, IoT, they would provide you with a reference architecture at this particular location. If you want to go in for machine learning, so they provide a reference architecture, how people would do. So these are like design patterns when we talk about the software development. So they provide you with reference architecture. So you can refer this one and base your architecture, maybe with minor tweaks as and when required, but then you can do this. And yeah, free trial of AWS accounts for all your hands-on. But then, as I said previously, you've got to be very careful when you actually create your AWS free account, because you never know when the charge will come back. Although I forgot to mention that in my case, they reverted the entire charge, because they said we can see that you have not used your charge, but then be careful next time. We'll not revert this next time around. So they were courteous enough in that case. And then there's this quick labs which you can do. This offers you online AWS environment without you having to create your own thing. So yeah, that was primarily from my side. The key takeaways.
Yeah,
from
we can go back to Q&A session slide.
This one, yeah.
Yeah, if people have questions, because we're already late, so we can take quick questions if people have.
Yes. So anybody?
So how do we integrate this with Jenkins or DevOps? So do we have some we have to just click URLs and links and it will be auto deployed in this AWS?
No, you integrate this with what?
Jenkins pipeline or CI/CD mechanism, all this.
Okay. Yeah, basically, you can do this. One is they've got their own pipeline as well. So it is very similar to what Jenkins is offering. But in our case, in my company, we don't use their pipeline. We actually integrate this with Jenkins, wherein the moment somebody uploads the code, it triggers a Jenkins build. After triggering the Jenkins build, it builds your entire set of artifacts. The artifacts are actually put on S3 location, and then it triggers a CloudFormation update stack. So what it does is it updates your stack with the latest artifacts. It does a code deploy of your latest code, and your stack is up and running. So it's seamless almost in that case.
Okay, thanks.
Yeah, any other questions?
Yes, I have one question. We are using Azure, and I have done certification in that. But around 3 years ago, I did this AWS course from Clouds Academy.
Okay.
So my question is that I'm not using AWS in my day-to-day work. So
Hello.
Yeah, hello.
Hello.
I think there is some disturbance.
I could just hear the half question and then nothing after that.
Yeah. Okay, so I think he's dropped back.
Okay.
He comes back again, then we can take the session. Or else, if you have any other questions, then we can take it. Okay. I think no other questions. Okay, we can proceed with the next slide, Dr. Bhai.
Okay, fine.
There is disturbance from your end also now. The background noise. Okay, Kamar Bhai, if you can go on mute. Okay, yeah,
Okay.
fine now.
Yeah. Okay. So basically, this is for the key takeaway part. So we covered what is cloud computing, what are the components involved, tenant onboarding. There's no separate, instances created for catering to different customers. It is all the same hardware behind the scenes, which is catering to all the tenants, which is there. We had a heads up at AWS and the basic services, which somebody would start off with when they start using AWS. We had a look at AWS related roles, job, and basically, one thing I would like to say is, if you want to start something, there's a startup idea in mind. Now is the time to start, because in the previous times, if I want to try out something, I would have to, for example, blockchain. Now blockchain needs a very heavy machine to run behind the scenes. So if I had to try to buy that machine, but now it is just pay as you go model. So you use it, you throw it back, and then if it works, it works. Otherwise, you don't have much to pay to those guys. So basically, this was thing. And one thing is, avoid vendor lock-in. So even if you are using AWS or you are using Azure, avoid vendor locking. What I mean is, so if you are using a EC2 instance, or for example, if you are using a SQS service, create a wrapper over that particular service. So tomorrow, if you want to go back to a different, messaging service, you are not locked with the AWS code base. So create a wrapper, use the wrapper, use the service via the wrapper, so that behind the scenes, if you want to tomorrow switch over to Azure, you can very easily do that without having to rewrite your entire project. So that was it. And then, yeah, this was, one of the points that we wanted to highlight, that all these technologies, all these, upcoming trends, they are very good. But then we should not forget what we are sent for. It is not for this. This is a means of getting our bread and butter. But then, we need to make sure that, wherever we are, in whatever state we are, we offer these prayers on their own time. Meetings can be postponed, meetings can be rescheduled, but then we need to somehow find time for this one and understand what Allah has a message. Allah has message for us. Basically, what are we trying to achieve just by behind these worldly? So, just want to put these points in the slide. So, Muzammil bhai, anything you want to add?
Yeah, the person who was dropped off, he has sent me an audio message, so I'm just playing it.
Sorry, the battery of my laptop was dead.
Okay.
My question is that how can I integrate my Microsoft DevOps tool, because I have not used AWS before. Although I have the theoretical knowledge of AWS,
Yeah.
I want to integrate my TFS or my online Visual Studio, TFS as a suite for the for the release management. I want to use that particular MS DevOps tool in AWS.
Okay, so that was the recorded message. So hope you got the question. If you can answer it.
Not exactly, because by integrating, what was the intention behind, and which services was the integration for? So maybe we can talk.
So I'll ask him to get in touch with you personally after this meeting.
Sure.
Okay, so go back to the next slide. Okay, feedbacks and suggestions. Like now, the first feedback I have now for our side is like we are late, so because of some technical issues. So sorry for that. You can give feedbacks on our Telegram group, or this video will be uploaded on YouTube, and you can give the feedback on YouTube as well. You can share this link, the video link, with your colleagues so that they also get benefited. And if you have any suggestions, or you need personal guidance or something like that, so we are here. You can get in touch with Arfat Bhai for AWS related things. And yeah, that's the last slide that we have. Okay, so if you have any suggestions or feedback of this training, then you can share it here, or else we can discontinue this meeting after 1 minute. I'll wait for 1 minute, then we can discontinue this.
And before that, once again, sorry for the delay of the technical glitch from my side. Just delayed by almost half an hour.
Okay, anyone else wants to have say some words?
Yeah,
How was
this is Mohsin Mujawar. Assalamu alaikum. So it was a nice initiative, Muzammil bhai and Arfat bhai. It is it is really helpful session to give a heads up on and if anyone wants like me as a developer, if I want to start this kind of as a career path, it is really a good informative session for me. So thanks a lot and Jazakallah khair. Thanks a lot for that.
Yeah, thanks, Mohsin bhai. Yeah, if anyone wants to share its feedback, then yeah, welcome.
Yeah, it was a great pleasure. Thanks, Mohsin bhai. Thanks, Muzammil bhai and Arfat bhai for this effort and bringing us on the same platform. So actually, I was planning to pursue my career in MuleSoft. After listening to this video and this session, I'm fluctuating my mind to AWS now. Thanks for
Okay.
that. Jazakallah.
Yeah. Yeah. Anyone else, or we can drop off? Okay, I think we can drop off. It's almost 11 o'clock now. So I'll upload this training on YouTube, and then people can share the link. Okay. Thank you. Thanks all.
Thanks, guys.
Assalamu alaikum.